Hey, I'm starting you off a little different view today. This is how exciting chemistry is. A cat cannot get up, a stupid cat, and across the street, which you can't see very well, is Mr. Turner's house. All right, so now let me go back to my desk. Are you getting sick watching this? All right, here's my desk. Let me set you up. Hang on, don't yell at me. All right, so you got to see the cat. There you go. Hey, this chapter is almost done, and I know some of you are finding it a little more difficult. Just hang in there. Just hang in there. We're almost done. Then we'll go to eat much easier stuff. Okay? Remember, next week is spring break. Ain't doing nothing over spring break. The first thing, if you don't mind, that you should get out is your homework, which would be 2 problems, and it's titled, I Am Old. Okay? Now, maybe some of you struggle on this. It's okay. Just keep trying. It's not a big thing. Some of you are internalizing stress. No, you're not. You're just trying. Maybe you'll pick up something. Maybe you won't. All right. It said this stuff had been around for 52 years. It said the half-life was 13 years. So 52 divided by 13 is 4. The junk has lived through 4 half-lives. All right? It said you start with 1,000 grams. Every half-life it gets cut in half, and I call this booping. So I went from 1,000 to 500. That wasn't the number they gave. So then I cut it in half again. Still wasn't the number they gave. Cut it in half again. Still wasn't the number they gave. Cut it half, boom, 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 boom. 4 half-lives. 4 half-lives. 1, 2, 3, 4, touchdown Cougars. 4 half-lives. See it there? Second one. It said they started with 256 grams, and they say it ended with 4. So I just started cutting in half. Boom. Once. Twice. 3 times a lady. Boom. Boom, and I ended it with 4. So I just took the original number and kept cutting it in half, half-life. Keep realizing, like on problem number 1, it says there's only 62.5 of the stuff left. No, there's actually 1,000 grams total left. Only 62.5 is the original stuff. The other 940 grams, give or take, 937.5 or whatever it is turned into something else. Okay, can't just disappear. So now I boomed it, and that was 6 half-lives. They told me the half-life, or the total time, pardon me, is almost a year. Almost a year. So I took 318 days divided by 6. The half-life is 53 days. Are those too hard? Okay. Here's what I want to do. I want to teach today's stuff real quick, and then this is the last of the meaty part of this chapter. And then we'll have some much easier stuff, and then we'll move on to a chapter that's 10 times easier. Okay, so if I was you, I'd pull out your notes, and I would title it, Carbon Dating. Okay? You hear sometimes they talk about this in the news and stuff. How do you know how old an object is? How do you know how old it is? If it's a tree, I've heard count the rings. If it's a person, just ask them. All right? But what if it's a rock or a bone or something like that? How do you know how old it is? Okay? That's where carbon dating comes into play. Now, carbon dating may tend to step on the toes of some religions. I don't expect you to buy carbon dating and go, oh, it's the gospel, it's the truth. I just expect you to know how it works. And in fact, if you are deeply religious, sometimes it's nice to know how the other side thinks or works to maybe disprove it or approve it or whatever you want to do. So I'm not saying, take this as the deep. And the reason I say that some religious groups don't like this, some religious groups say the earth is anywhere from about 6,000 to 10,000 years old. Okay? And not all. I mean, I can't speak for every group, and I don't know them all. But in general, somewhere around there, those in my 0 hour, I looked it up, and a majority of my 0 hour, you have it around 7,000 years old, if you know what I mean by my 0 hour. Okay? But again, everybody can have their own beliefs. The problem with this is carbon dating has things much older than this. Well, if this is the creation and the time of Earth, how do you have things much older? So carbon dating and then this, they clash a little bit, but it's no big deal. They clash. Okay, life goes on. All I expect you to do is know about it. So the purpose of carbon dating is to figure out how old an object is. Now, I'll be honest with you, if it's a really, really old object, they'll use uranium dating. Okay, they'll use uranium. I think carbon dating is good to about 57,000 years. And uranium dating is like billions of years. Okay? So I don't really want to worry about that too much. But uranium dating is like for super, super, super old things. All right. So this carbon dating. Carbon dating uses carbon-14. Carbon-14, is radioactive, and it's all around us, and in fact, it's in us, and don't worry about it. It's not going to shorten our lives or cause dilemmas in us. It's just there, okay? Carbon-14, that means that carbon-14 inside us is decaying, disintegrating. Remember how we talked about little particles going, whew, pew, pew, pew. Okay? Now, how'd that carbon-14 get in you and I? How'd it get in us? All right. Well, there's Mr. Sun. Do you realize that's the biggest ball of radiation we got close to us? That thing is radiation. Okay? And the sun gives off cosmic radiation. We learned that back in the wave chapter. Remember, that was the highest energy. So here comes this cosmic radiation. And there's atoms in our atmosphere. Okay? And this cosmic radiation strikes some atoms. And what it can do is it can make an energized neutron. Now, I won't just kind of understand the concept here. So in our atmosphere right now, there's lots of nitrogen-14, okay? This neutron comes over and goes, boom, smack, baby. All right, and what it does, just understand the concept. You don't have to be real detailed here, is it makes for a neutron capture. And this happens all the time in our atmosphere. When it captures the neutron, it produces carbon-14 and a proton is emitted. Pew! But now there's our thing. Okay, there's our carbon-14. Carbon-14, that is radioactive. So now this carbon-14 is out there in the atmosphere. And if it bonds with some oxygen, now you have carbon dioxide in the atmosphere that's radioactive. Okay, I will never ask you to put this on test. Just kind of follow how this all works. So now, there's a tree. Okay, it's a tire swing. Biology people, what do trees take in? They take in carbon dioxide. And if some of that radioactive carbon dioxide, remember the radioactive carbon-14 is bonded into this tree will take in that radioactive carbon dioxide. Now I say tree, other plants too do this same process via photosynthesis. And if you remember what trees give off or plants give off, they give off oxygen. Not the smartest guy in the world, but CO2 went in, O2 came out. That means the carbon-14 stayed in the tree or the plants or whatever. So now that carbon-14 is in there. This is my cow. Okay? What's that cow eat? Well, the cow eats the plants that have the carbon-14 in it. Okay? And then man comes along, or woman. Pew, shoot the cow. We eat the meat. Now the carbon-14's in us. And you vegetarians going, oh, I'm safe. I don't eat meat. Superstars, what do you eat? If you don't eat meat, that means you eat plants, and it's already in the plants. So vegetarian, meat eaters, it doesn't matter. Vegans, fruitarians. There's a type of people that only eat fruit that's already fallen off the tree so that they don't have to pick it from the tree and rob it of its life. They only eat the fruit that's already on the ground. Moral of the story, carbon-14 is in all of us. Okay, carbon-14 is there. It's radioactive. Carbon-14 has a half-life of 5,730 years. Now, carbon-14, when it's fresh, when it's newly made, remember how I talked about the little pews coming off of it? Fresh carbon-14 gives off 15.3 decays per minute per gram. That means 15.3 pews per minute on average. Okay? That's for fresh. Brand new carbon-14. The sun made it through the cosmic radiation. Boom, in it goes. All right? Now realize when you perish, sadly we'll all perish someday, your body will not be taking in any new carbon-14. Our bodies stop taking it in because we're not eating anymore. And so the freshest we'll have is 15.3, and it's only going to go downhill from there. Okay? I got 2 examples on how this works. Relax, the homework tonight, maybe one problem. I just want you to understand the overall idea of this. Okay? Now, my first example is half real, half fake. Okay? Half real, half fake. They found this board up in the mountains in Turkey. Now, this board was old. You could tell it was old. Okay, way up in the mountains. This board is old. Looks like it's been created like, in the old days, they didn't have fancy machines to make boards. That almost looked like it was made by, they call it axe cut, where you can see the little marks where the axe made it into this nice board. So my question to you is, how is a board that's really old found way up high in the mountains? Okay, I doubt somebody's going to walk it all the way up there. Now remember, this example is half real, half fake. Okay, I'm obviously cheating on the numbers and all that. Well, how do you think a board gets way up there? Some people hypothesized that it's part of Noah's Ark. Okay? And it would make sense why it's up in the mountains, because if the earth was flooded and the ark would only hit or land way up high on a mountain. Well, this would be revolutionary. This would be awesome. It's so cool to know if we had part of Noah's Ark and we knew it. So they want to go, all right, let's date this board and see what time frame it came from to see if it was really part of Noah's Ark. So they're going to carbon date it. Okay, they're going to carbon date it. Now remember, this board is part of a tree, and it's taking in carbon-14. All right? Here's where this gets a little weird. They put this piece of wood in a fancy machine. So there's that piece of wood. They put it in there. And remember I told you it's giving off the little pews, pews, pew, pew. This machine spits out a number and says, on average, it's giving out 0.95625 decays per minute per gram. And you're like, well, how does that help us? Well, I told you all fresh carbon-14 starts at 15.3 decays per minute per gram. That's fresh carbon-14. I mean, obviously this tree is dead, so it's not taking any more fresh. So what I did is I pulled out a calculator and I did a half-life. So I went, all right, I took 15.3 and I cut it in half. And now it's giving off 7.65 pew, pew, pews per minute. That's one half-life. I did it again. I divided by 2 again. 2 half-lives. I do it again. That's 3 half-lives. I do it again. You're like, why do you keep doing it, dude? Well, watch this magic. Okay. Do you agree? That's what the machine said. Took 4 half-lives. Now, did I give you the half-life of carbon-14? I did. Look at this. Look at this. The half-life of carbon-14 is 5,730 years. So it's gone through 4 of them. So this board, guys, this is the fake part. This is all, I made this up to give us nice, clean numbers. This is fake. Okay, so don't think I truly found Noah's Ark. Okay. So it'd be 22,920 years old. Okay, the board they did find, I found out the time frame was different. How it got there, I don't know. I know a lot of people will come forward and say they've found religious artifacts. I think that Jesus was wrapped, excuse me, I don't know this very well, but wrapped in a shroud, wrapped in a blankie, okay? And I've heard of people coming forward saying they have found that blankie. And some people even say the image, because of it was wrapped around Jesus, and the image of Jesus somehow was in that blankie, okay? And lots of people come forward, and if that's true, if they have the blankie he was wrapped in, guys, you can't put a money value on that. That is just part of history. It's amazing. And what they find a lot of times is they'll carbon date this, and these people are pulling fakes. They are just trying to cash in. You know, it's some sheet from Walmart that they, you know, weathered and did all these things on, and it's not that old, and they're like, you jerks, okay? That's not very nice to do. All right, so that's kind of where carbon dating is used to disprove things. Now, I said I have 2 examples. Okay, here's my second one. Uh-oh. Did I only do 1? I only did 1. I lied. We're only doing 1 example. Okay? 1 example. Now, sorry, looking at my notes. Sorry, I got a little out. You know, for the age of Earth, I told you the uranium date. For older objects than carbon-14. For older than carbon-14, they use uranium-238, and its half-life is 4.5 billion years. And some scientists, some people, take it as you will. Don't say I'm preaching the gospel. I'm just telling you what I know. Some people say the Earth is about 4.5 billion years old, which means we've gone through 1 half-life of uranium-238. Okay? Now, here's where this is also used. Back in 1996, okay, boat race time. Y'all gone to the hydroplanes, the boat races? I don't know if you know, but during the boat races, they change the water level so that the water level is actually up higher. And what it does is it makes a bigger race course. Because the water's up, more water across, bigger race course. And there was some people out inner tubing, playing in the water. And this dude stepped down right along the shore. And he stepped on something that he felt kind of smooth. And he thought that was odd. He found a skull. Okay? Eventually, this skull was to be known as Kennewick Man. And it was more than a skull. It was a whole body. Okay, it was a whole body. And it's because the water level was up. It was washing up higher on the shore than it normally does. And it eroded some of the dirt. And so that's why Kennewick Man was uncovered. Some people believe Kennewick Man was actually, in a sense, buried there. Just the way the body was laid out, they thought no way could that have occurred naturally. The reason Kennewick Man became a hot topic was they carbon dated him. Now I'm paraphrasing here, but they found him to be older and a different skeleton type than they thought of people in our area. Okay? And there was a fight over Carbon Man or Kennewick Man to figure out who he belonged to. The Native Americans said he was one of theirs. I mean, there were court cases for years, and it just the age, everything was just a little bit odd about this. I think the ultimate say was he was Native American, and after all this research, the Native Americans said, you know, that's not proper. It's their ancestors. You know, you can't just treat their ancestor, even though, you know, go, well, they're dead. Well, it's still the spirit of the bones in the body. And so they wanted him back, and I think they gave him a proper burial again. So Kennewick Man caused a lot of controversy on his age and all that. But now he's back buried properly. Where, I don't know. Okay? So I would like you to try one problem tonight. Okay? The homework tonight, one problem. And it's called bleeding forehead. One problem only, okay? And then we go to a little bit easier stuff, and then we'll be done. All right, peace.